Hello everyone, you are welcome to today's class. In this class, we're going to continue our class, and we're going to look at another concept entirely, and that is modular arithmetic. So all of these, in this video, we're going to look at these aspects specifically. That is, the objective is that we want to understand what we refer to as cyclic events and a concept of modular arithmetic. Then after that, we then look at how to simplify modular arithmetic, then how to find equivalent moduli. Now, when we talk about cyclic events, these are events that happens at regular interval. That is, from one cycle to another cycle. That is, when you move from the beginning to the end. So you go back to the beginning again, just like a menstrual cycle of our female counterpart. They move from once they start their cycle, it will end at a particular number, at a particular day, then to go back to the beginning again. That's what we call cyclic event. The same thing happens to weekly events, Monday to Sunday. Then after Sunday, we go back to Monday. You understand? It's not something that is continuous. You understand? That's what we call cyclic events. The same thing with our clock. So from 12, we move to 1, 2, 3, back to 12. 1, 2, 3, back to. You can see it is what? Cyclic. So cyclic event. So we want to look at that concept. That will now help us to understand what is referred to as modular arithmetic. Just like when you have, look at this. This is the clock. This clock. Let's look at this clock. So we have 12 here. So let's say we have 1, we have 2, we have 3, 4, 5, 6, 7, 8, 9, 10, 11. Now we have, the middle, the hour hand is on 12. This is, you can see, is a circle, it's a form of circle. You're starting from 12, you move around, go back to 12, to continue again, to complete the cycle. Now, let's look at this. If we have, let's say, assuming the time now is example. So the first one, the time now is, let's see, 10 o'clock. 10 o'clock. What would be the time in the next A, let's say 6 hours, then B, let's say 28 hours. So let's look at these two examples. So the time is 10 o'clock now. So what we're going to do, we're going to put the and, the pointer, the R and let's have it on 10. So what that is the time is 10 now, and what will be the time in the next 6 hours? That is, after 6 hours, what time will it be? So it means we are going to count 6 clockwise, and wherever we get will be the time. So we are not going to start from 10. So the next one, R, will be from 11, 12. So that will be 1, 2, 3, 4, 5, 6. So that means for A, so once we move, that means the next R will be what? 4 o'clock. That we are saying 10 plus 6 hours gives what? 4 o'clock. You understand? But if you look at this addition, when it's 10 plus 6, how come would it be 4? You understand? You ask yourself, what? Ordinarily when we count, we have counted from here 1, 2, 3, 4, 5, 6. We stop at what? 4. That is why it's 4 o'clock. 4 o'clock. But we asking that, why will it be 4? 10 plus 6 is supposed to be 16, right? Now, because it is cyclic event, it is from 1 to 12. If you look at 10 plus 6, That's supposed to give us 16. But 16 is more than 12. 16 is more than 12. What we're going to do is we divide 16 by 12. When you divide 16 by 12, it will give you what? 1, remainder what? Remainder 4. It is that 4 that turns to our what? Answer. I believe I'm making sense. So that is what we refer to as cyclic what? Event. You see that 4 o'clock, our answer is 4 o'clock. But if you want to write it, because clock addition is not the same thing as normal addition. We say 10 plus 6, 10 plus 6, 10 plus 6, which is 16. It's not the same thing as this one. Because we have 10 plus 6 equal to what? 4. It's equal to 16 rather. So in that case, we want to write this to be 10 plus, we now put something like clock like this. As in cycle. We put cycle inside it, plus 6 is we are not going to use equals, we use this symbol, right? It's equivalent to what? 4. Is that clear? So this symbol here means equivalent to or congruent to. So this symbol means equivalent to or congruent what? To. Either of the two, you are saying the same thing. Hope that is very clear. Now, that is down the first one. The second one, which is B part, we have 28. So that would be, so addition again. So we after 28 hours, 10 will now be 10 plus 28. What will 10 plus 28 be? That will be what? 38. So we're now going to divide 38 by what? 12, because we're working in 12 hours. But before we do that, so let's count. What to count 28 after 10? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. That we are going to be what? 2 o'clock. So let's now see it. So this gives us 28. Divide it by 12. So that gives what? 3, remainder what? That's 66, remainder 2. So you can see we got what? 2 here. And our answer is. So instead of you moving in, because it's not going to be the same thing, but I will move on. You understand what I'm trying to say here. So instead of you to be counting to 2, so just go through this method. 10 plus 28 is equal to what? 38 divided by 12. That is what we're working with. Then 3, remainder what? Remainder 2. So in that case, we can say that 10 plus 28 is equivalent to what? 2. Right? So that means that the time will be 2 o'clock. I hope that is clear. So that is the concept of cyclic what? Event. It's not always going to be what? 12. For example, you can have something like this. You can have the cyclic event to be 0, 1, 2, 3, 4, 5. You can say this one. This is another cyclic event. We can make use of this one to solve any problem. Is that clear? So that is what we want to look at in this class. So what do we mean by modular arithmetic? In short, modular arithmetic is talking about cyclic events. So it is a system of arithmetic in which numbers wrap around when they reach a particular number, just like this. So this is on 12. So once the this pointer moves from 12, it should go back to 12 and start all over again. So it is a system of addition in which numbers was wrapped up after they reach a particular number, they start all over again and so on and so forth. That's what we refer to as modular arithmetic. So we're going to let's look at this now. Modular arithmetic is a system of arithmetic in which more numbers wrap around after they reach a particular certain value. Now let's look at this cyclic event. You can see this one is from 0 to 5, right? So how many digits do we have there? We have 1, 2, 3, 4, 5, 6, right? So we have 6 integers there. So what are we going to do? Assuming we have the pointer to be on 2. We have the pointer to be on 2. Now, Because what we have here, we have 6 integers here. This is under mode 6. It's under what? Module 6. Modular 6. You understand? So if we now have 2 plus 6, what will be our answer? 2 plus 6 must be equivalent to what? So that means after 2 here, we're going to count 6 clockwise. 1, 2, 3, 4, 5, 6. So the answer will still be what? 2 in mode 6. You see, mode here is short form of writing what? Modulus, right? And modulus, the plural of modulus is what? Moduli, right? Is the plural of moduli. So it's still the same thing as 2. Just from what we just discussed now, that is 2 plus 6 must be equal to 8. Divided by 6. That is 1, remainder what? Remainder 2. You can see. And that means 2 plus 6 is equivalent to 2. But we're not going to write the plus in this form. It will be what? In form of what? 7. That will show that this is under modulus because it is cyclical events. Is that clear? So it is equivalent to what? 2. In mode what? In mode 6. So we can have another one. We can have like 2 minus. So this is minus. Put it in circle. Minus 4. That is before. We count backward. So counting backward 1, 2, 3, 4. The answer will be what? 4. Right? So the answer will be what? 4. How can we get 4 from here? So if you look at it, because it's in mode 6. 2, we cannot subtract 4 from 2. Because in mode 6, add 6 to this, that gives us 8. 8 minus 4 gives us 4. Is that clear? So that's why we have this one to be what? In mode what? In mode 6. We are still going to look at that in details. We are going to have look at addition and subtraction of modular arithmetic. So, but for the purpose of this, we are only looking at this, the concept. We want to understand the concept, what it means. Then we want to look at how we simplify modulus. Then how equivalent modular that we have. Those are the things we want to look at in this video. But in the next video, we will be looking at addition, subtraction, multiplication of modular arithmetic. I hope I'm making sense. So let's look at simplification of modular arithmetic. One now is simplification of modular arithmetic. So when you ask to simplify anything, they're asking you to reduce it to its lowest term. Just like when you have fraction 2 divided by 10, and I used to simplify this. It means you are reducing it to its lowest term. That is going to give you what? 1 over 5. So the same thing will be applied there. So we want to see, because this is saying that 2 divided by 10 is equivalent to what? 1 divided by what? 5. So what will these 76 be equivalent to? That's what we want to look at in this video. So in this portion of the video here. So solution here now will be, so since it is a mode 5, so we're going to use 5 to divide 76 and see what will be the remainder. Don't forget the fact that under modular 5 here, under this mode 5 here, we say that when you use 5 to divide any number, this 5 to divide any number, the maximum remainder you can get is what? 4. So you can get 0. If you divide 5 by any number, you can get 0. You can get 1. You can get 2, 3, and 4. You can't get 5 as a remainder when you are dividing by what? By 5. So which means the highest integer in modular 5 is what? Is 4. I hope I'm making sense. So in that case, let's have the 76 divided by 5. So 76, 5 in 7, that is 1, remainder 1. And 16, that is what? 3. Sorry, it remainder 2. It remains 2. And 26, that is what? 5. So remainder 1. So remainder 1. So which means we are saying that 76 is equivalent to 1 in mode 5. So that is what we call simplifying mode. So we are able to simplify what? 76 mode 5 to be equivalent to 1 mode 5. I hope this is very clear. Then for the second one, for the second part here, so the second part here, which is 340, so we're going to use it to divide the mode 7. So that is 340 divided by what? 7. So what are we going to get? So we're going to have 7 in 34. So that is 4, which is 28. It will remain 6, right? So 7 in 60, which is 8, which is going to give us 56. That remains 4. Remainder 4. So you notice that this mode 7, the same thing happened to mode 7 here. So we can't get 7 or a number above what? 7, right? So that is we have 4 here. So that means 340 is equivalent to 4 in mode 7. So you notice that we are having one digit. So that is simple. We have simplified to the extent we are not having 2 digits. We are not having what? 3 digits. Just only one integer rather. Hope this is very clear. So the next we move to equivalent line. So that's what we're going to look at in the next aspect of this video. Thank you. Alright, so here we want to consider equivalent modular. So when we talk about equivalent, you know, I made mention of something. I said that this symbol means equivalent to. So what we are saying that 2 integers will be equivalent. For example, I have 23 here, 45 here. Are they equal? They are going to be equal if in the mode given, they are going to be equal if this one has a remainder and it's equal to the remainder of this one. That means that 23 is equivalent to what? 45. So it's just like what to prove. So just like what I said, 2 integers are said to be equivalent when they have the same remainder. So examples states whether the following pairs of numbers are equivalent in the modular what given. So let's look at the first one. So the first one we have 67 and 94 in mode 8. So what we're going to do, we're going to find 67 in mode 8. So that means 67 divided by 8 will be equal to what? 8 in 67, that is 8, which is 64. Remainder, that's remainder 3. So we look at 94 again. So 94 in mode 8 now. In mode 8. So that means for that, therefore, that means 67 is equivalent to 3 in mode what? In mode 8. Then we confirm this again. 94 in mode 8. So that is 94 divided by 8. So that is 11, which is 8. 94 minus 8. So this is 14. That is 6. So that's remainder 6. So remainder 6. Now, from what you can see here, can we say that means 94 is equivalent to what? 6 mod what? Mod 8. So if we look at this, the remainder we have remainder of 3, we have remainder of what? 6. Are they equivalent? So in this case, we're going to say, therefore we conclude that 67 and 67 is not equivalent to what? 94 in mode what? In mode 8. I hope this is very clear. Second example. So we have 140 and 404 in mode 6. So we're going to test for both again. That is 140 divided by 6 will be what? We want to get the remainder. So for 6 here, that is 2, which is 12. Remainder 2 in 20, that is 3, which is what? 18, remainder what? Remainder 2. Right. So let's check for 404. 404 divided by 6. So 4 in 36 in 40. That is 36, which is 6. Remainder 4 in 44. That is 7. Remainder. So that which is 42. Remainder 2. So you can see they both have the same remainder. So we can conclude that 140 is equivalent. Therefore, 140 is equivalent to what? 404 in mode 6. That is, in this mode, 140 and 404, they are equivalent. They are the same. They have the same remainder. Then the last one we have here, which is number 3, we have 72 and what? 32. So we check in mode what? In mode 5. Right. So we check 72 divided by 5 will be equal to 7 here, 5 here, 1, remainder 2 here, 4, remainder 2. Right? So we check for 32 again. 32 divided by 5, that is 6, remainder what? Remainder 2. Therefore, we can also conclude that 72 is equivalent to what? 32 in mode 5. So that is that on this. You can see this is just the introductory part of this modular arithmetic. So in our next class, we're going to talk on addition, subtraction, and multiplication of modular arithmetic. Before we look at division of modular arithmetic and some application of this concept. So if you find this video useful and helpful, kindly give us a thumbs up. And if you are new to this channel, so don't forget to subscribe and make sure you put on your notification bell. So anytime I release video, you to get notification of it on time. So I wish you best of luck. Bye for now. Thank you.